representing data, example 7. This is another example where the histogram has actually been provided for us and we're asked some questions about it. This was on an exam quite a few years ago and it tripped a few people up, so it's really important that we have a look at this one. So these are times taken to do a fun run for 140 runners. Now the fact that it's 140 runners is really important and we'll come back to that. So it says use the histogram to calculate the number of runners who took between 78.5 and 90.5 minutes. So 78.5 to 90.5, it's basically asking us, what does that represent there? Now it's really tempting just to find the area of that bar. However, we do need to be a little bit careful because if you remember on example 5, we said the area was proportional to, that's what that symbol means, frequency, but not necessarily equal to it. It's proportional to, it's a multiple of. So I'm going to work out the area underneath this whole graph. Now the scales are a little bit difficult to read, but hopefully on your paper copy you'll be able to see it quite well. So the area, if I just work out each bar one at once, the first bar is 6 times 1. It's got a height of 6. This actually works out to be a width of 1. If you compare it to this bar here, you'll see that they both have a width of 1. The next bar is a height of 7 and a width of 1. The next one has got a width of 4 and a height of 2. And I'm just going along finding the area of each rectangle. You might want to pause at this point and see if you can work these out for yourself. I'll keep going. So I think we've got 5 times 2. For the next one, 3 times 1.5 for the next one. And then I think the last one has got a width of 12 and a height of 1/2. Now it's tempting to assume that that would add up to 140, but it actually doesn't. It adds up to 70. So 140 runners is an area of 70 square units. So it's 2 runners for every 1 square unit. So let's have a look at this bar that we're interested in. It's this last one here. 12 times 0.5 is 6. So that's an area of 6 square units. So if it's 2 runners for every square unit, it's going to be a total of 12 runners. So don't assume that the area is equal to the frequency. It's proportional to, and in this case, the area was actually half what the number of runners was. So 1 unit represented 2 runners.